Hello kids, I hope you are well. Let's discuss today's NEET exam question paper. Now before we start with this session, let's discuss the chapters what we have got in these NEET exams. The first chapter I think so you would be knowing is an amines, second is biomolecules, third one is IUPAC nomenclature, third one ke baad next fourth in the sequence is isomerism. Fifth one is nothing but general organic chemistry, what we commonly known it as GOC, and the last one is hydrocarbons. So here we have got questions. Let's start discussing those questions one by one. And still, if you have got any query related to this after watching the even video lectures, you can come down to a branch anytime. Yeah. So let's begin with the first question. I think so you have got on the screen. I think so you have got over here one molecule called as ethyl bromide, and the first step what you can see on the arrow, it is written as aqueous KOH. Now basically aqueous KOH does what? A substitution. So let's write what must be the situation. So I've taken just the starting material, it's ethyl bromide. Now what I'm using on the arrow, I think so you know it's an aqueous KOH. Now aqueous KOH generally does what? Substitution. So what will happen from here, your Br and from your K will get lost outside as KBr. What are you going to get? The next thing what we will get is CH3, CH2 and OH. Now, before we start with the next point, child, this compound is known as ethanol. Now, what is the next step on the arrow? I think so, next reagent on the arrow is KMNO4 with acidic condition, and I think so we all know that KMNO4 is nothing but an oxidizing agent. So your alcohol will get oxidized to an aldehyde, aldehyde will further get oxidized to an acid. Why? Because our KMNO4 is a strong oxidizing agent. So here the answer is direct. What will happen? Here we will get nothing but 2 carbon atom carboxylic acid, because we have studied that primary alcohol always on oxidation gives a carboxylic acid with the same number of carbon atom. Now what we have got is nothing but called as ethanoic acid. Now what is the next step? I think so on the next step what we have, I think so what we have found out right now, ethanoic acid is nothing but the compound number B. Initially I think so what we had got is ethyl alcohol is nothing but compound A. Now what is the next step what we have after B? I think so we have to treat this with an ammonia. Now when you treat this with an ammonia on heating, basically what will happen? Your acid will get converted to its acid derivative which is called as an amide. So your answer is going to be CH3, C double bond O and NH2. I think so this compound, if you want to name it, as per the rule, I think so there are 2 carbon atoms, we can call it as eth, single bonded, so ane, and amide is the group what we have. The suffix name what we'll be using is an amide. So can I call this compound is known as ethane amide. Now one of the very famous reaction of amines what we know, which is when you treat an amide with an bromine in presence of an alkali condition, let it be NaOH or KOH. Let's say I've taken NaOH over here. What will happen? The important part of this reaction is what? Your carbonyl group what you can see in an amide will get removed by this particular process, and the answer what are you going to get is nothing but it's methyl amine or methane amine. That means child, in this particular process 1 carbon atom becomes less, and what is the name of this reaction, child, if you remember? It's an Hofmann bromoamide degradation. This is one of the very important reaction, child, which is used to step down the series. Is it term clear? So the correct answer for our this MCQ is, I think so, where is the methyl amine? Here. So your correct answer is C. Is it term clear? Chalo, let's proceed with the next MCQ what we have on the screen. Now I think so next MCQ is what? There is an organic compound A. So I'll just put it over here. There is an organic compound A which on reduction gives a compound B this compound B on further treatment with chloroform, I think so you can see CHCl3, and along with that you have got an alcoholic KOH. It gives you product C. Now this compound C on further reduction, catalytic reduction of course, gives you a compound called as N-methyl aniline. Now basically what I have done, child, if you see, I have converted my whatever the written script in a reaction form. Let's now try to analyze something from this. First, let's write the structure of this product what we have got. So here, how to write a structure? I think so the parent name is aniline. So can I put it over here as a benzene ring? What you can see, having over here as aniline part where you have got N. But now wait, you should know that methyl is attached to a nitrogen. So I put a methyl and then you put the hydrogen to balance it. So what I have understood from this, I have understood this is nothing but a secondary amine. Now, the question is what? Which reaction are we carrying out? I think so it's a reduction. So if reduction would have not been done, basically that means what? These hydrogens would have not been there. Suppose if you remove these hydrogens from that particular structure, let's see what do we get. This H and this H is removed. Will I get nothing but the structure something look like this, where you have got a benzene ring having N and having C. And not only this, child, I think so you should know this is one of the very important reaction, child, in chapter amines, carbolamine test. And in carbolamine test we always get isocyanate, so somewhere this is that isocyanate. So now isocyanate, first of all, what is carbolamine test? Carbolamine test is nothing but used for detection of primary amine. That means only primary amines can give you this carbolamine test. So here of course your product, this is the product C, correct? So now what would be your product B? I think so if you have got an isocyanate over there, that means this has to be a primary amine. So your product number B probably would be and aniline, what you can see. Now last, if you see this compound is also obtained on reduction. That means if you think opposite of that, that is oxidation, can I have instead of H, O? So what should be that compound probably? The compound probably should be nitro. And if you now you can revise that nitro compounds on reduction gives aniline, or that is amine. This primary amine on further carbolamine test, yes, it gives you isocyanate, and this isocyanate on further reduction gives you secondary amine. So here the most probable answer what we have. So correct answer is, in our case, is, I think so you can see very clearly that your D option, which is nitrobenzene, should be your correct answer. Is it term clear? Chalo. Let's proceed then third reaction. We are third MCQ. Now see, this is one of the very common question, that is what? Among the following isomeric C4H11N amines, one having a lowest boiling point. Now a child, very clearly, boiling point is one of the very important topic in concept called as physical property. And I think so we all know that your discussion of boiling point directly proportional to hydrogen bonding means if a compound has got a hydrogen bonding, its boiling point has to be obviously more. Now the question comes as what? We have got all amines only, and in all amines basically you can have hydrogen bonding, but we have done one more thing, that is nothing but what? Boiling point order for isomeric amines is what? Your primary amine has got a higher boiling point than secondary amine. Your secondary amine has got a higher boiling point than tertiary amine. Therefore, if you see in our example, the first example, I think so what you can see very clearly is nothing but a primary amine. The second example what we have is I think so called as a secondary amine as option B. In example C, if you see again it's a secondary amine, and in the option D you can see it's nothing but a tertiary amine. Now my question is, we have to find out the boiling point, but which lowest boiling point? So obviously as per the discussion your answer has to be tertiary amine. So the correct answer is D, which is a tertiary amine, because we have to find out the lowest boiling point. If they would have asked highest boiling point, then our answer would have been a primary amine, that's A. Is it done? Let's proceed to the next question, kids. Now here again we have got one reaction where they have told us to find out the Z compound. Now what is the first starting compound? I think so the first starting compound is nothing but ethyl chloride. Now what is there on the arrow? I think so it's nothing but a sodium cyanide. Now basically child, we have done somewhere in the previous chapter or in the prior chapter that whenever alkyl halide is treated with KCN or NaCN, we get cyanide as the product. So our product would be ethyl cyanide, or we can call it as propane nitrile. Now what? Further you have got over here that is nothing but nickel and H2. That means this condition is for hydrogenation, and we call this process as catalytic hydrogenation. What will happen child? Your cyanide group will get converted to an primary amine, but how? Let's see. So this is nothing but an ethyl group. You have got a cyanide which is C triple bond N, but since we know that addition will take place over here, so your pi bond will be broken and we just have to add H over here. So 2 H's over here and 2 H's over here. Have I got nothing but propane 1 amine. Now what is the next important step, which is the last step? So I think so what we have got over here after treatment with NaCN is the product X. So this is nothing but my compound X. Now after treating with nickel H2, we have got a product which is something called as Y. So now the final product what we need to find is what? Treating this with acetic anhydride. Now basically what is acetic anhydride? Now here just write the structure of acetic anhydride. Now what is acetic anhydride? Let's see over here. Now in acetic anhydride child, we have to just take over here, I'll just write over here as O, C double bond O, C double bond O and CH3, and it's a CH3. So this is nothing but acetic anhydride. Now what will happen child? We know that after means in acetic anhydride it's an acid derivative. We know that this part what you can see is nothing but a leaving group, and from here your active H will get lost. So the product obtained what it would be of this type: CH3, CH2, CH2, NH, and then you will have got this acetyl part. So can I call this process is named as acetylation of amine. So in our textbook this topic has been named under the topic called as acylation or acetylation of amine, and this is only nothing but our final answer. So I think so if you can match this situation, so out of all these cases I think so A looks very perfect to that. So correct answer of this MCQ is A. Is it done? Chalo, let's proceed to the next question. Now here this child question is based on statement 1 and statement 2. Now what is the first statement given to you? Aniline is less basic than acetamide. Now question comes as, what is a base first? So as per a definition, bases or base are nothing but electron pair donor is known as Lewis base. Now let's write the structure of first two compounds what you have got. If you see I have taken over here an aniline unit, and the second molecule which I have taken is an acetamide unit. Now, please over here now, if you see this aniline molecule, what you have got over here, and if you see this is an acetamide molecule, what you can see over here. Concept is what? You have got over here a nitrogen containing a lone pair. Here also you have got a nitrogen containing a lone pair. Now the concept is what? Since this nitrogen gets involved in delocalization, that means this lone pair of nitrogen is involved in conjugation or resonance with benzene. Same way over here also lone pair of nitrogen gets involved in resonance or conjugation with carbonyl group. So in both the cases, if you see, lone pairs are already getting involved in some delocalization, so they are less available for a proton. That means they are less available for donation. That means both of them are a weak acid. But now still if you want to compare, over here you can see lone pair is getting involved with benzene, which is nothing but a weak resonance. Whereas in case of second acetamide, lone pair is getting involved in resonance with carbonyl is a strong conjugation or a strong resonance effect is there. So basically what is the concept? Concept is like this: basicity is inversely proportional to lone pair electron involved in resonance. So in both the cases, if you see, basicity is less, but if you still compare out of these two, who will be more basic? I think so this will be more basic, who? Aniline. And if you check this compound, it's nothing but less basic. That means as per our statement 1, if you can see, your statement 1 tells that aniline is less basic than acetamide. Now this is not true. That means I can mark this statement number 1 as an incorrect statement. Now at the same time, when you see the second statement, what is the statement given? In aniline, the lone pair of electrons on nitrogen atom is delocalized over benzene ring due to resonance, and hence it's less available for a proton. Yes, I think so, that is also I have proved it is less available. That means your second statement is correct. Now as per the situation, out of 4 options given to you, your first statement is incorrect and your second statement is correct. So first statement is incorrect, but second or statement number 2 is correct. I think so the correct answer in this particular case has to be your option A. That means a correct answer is A for this MCQ. Is it clear? Let's proceed to the next one. Now child, if you see in this reaction or in this particular MCQ, which of the following compound gives dye test? Now basically when you talk about dye test, it's nothing but azo dye test. Now basically who does show azo dye test positive? So I'll just give you a brief of one reaction what we have in the syllabus. Whenever if you have got an benzene diazonium chloride as a compound, when it has been treated with any aromatic compound which contains donating group, let's say it is OH or let's say NH2, anything. So what will happen under basic condition? Under basic condition. Now what is that basic condition, child? It's nothing but in presence of OH minus ion. In presence of OH minus ion. What will happen? Let's see over here, child. First of all, you should know one point very clearly, and that's nothing but donating groups. Generally, over here it's an aromatic ring. So aromatic ring likes to undergo, or benzene ring likes to undergo electrophilic substitution. Since it's a donating group, so over here your product will be either ortho or para, but as per the concept, para would be the major. So I'll take over here your para H. From here, your Cl and H will get lost. So the answer what you get is nothing but what? A benzene unit containing a nitrogen. I'll even write in open form as N. Again you have got a benzene ring. And then you have got over here as OH. Now my question over here, child, is this is the product what we have got. So whenever a diazonium salt is been coupled with any aromatic compound containing donating group, it will give you a product which will have got some color. Hence we use this as a laboratory test called as azo dye test. But now the question now comes is, sir, what is the name of this compound? I think so this compound we have already studied in the syllabus as para hydroxy azobenzene, and we know that it has got some color, and I have told you also to remember it as mark O. So this compound has got a color orange. Now what is important? Sir, how you are going to relate this? Yes, now I'll relate it. Now you tell me one thing, which compound out of this can show a dye test? Now basically for that we require two material, one is phenol and one is diazonium salt. But now question comes is, diazonium salts are prepared from aromatic primary amine, and which aromatic primary amine normally we have seen? It's an aniline who does show formation of a diazonium salt. And how it is formed? Basically how it is formed, you can see over here that this is nothing but a starting material to give a diazonium salt, which is going to get later on an azo dye. So out of 4 options what you can see, the most probable option is option A. So over here your correct answer for this MCQ is A. So let's proceed with the next MCQ, kids. Over here we have got a next question, which is, which of the following reagent can be used to convert benzene diazonium chloride into benzene? Now basically again that's the reason in the previous MCQ only I have told something about diazonium salt. Let's put it properly. I have got a benzene with something called as N2 plus and Cl minus, since it's a benzene, correct? Now treat this with something out of this 4. Now in our syllabus we have got one compound called as phosphofinic acid, which is nothing but H3PO2. Along with that I'll take some amount of water, which I'll write it like this, and now what will happen? You can see diazonium salt basically will have a loss of N2 gas. So byproduct obtained would be over here as N2 gas. Now second part, do we have got this Cl will combine with one of the H. That's the reason I have written water in an open form. So you will have got over here as an HCl is a byproduct. Now one more very important thing, you can see very clearly this oxygen will combine with this phosphorus. So the product formation would be, next one would be H3PO3. Is the term clear? So what you have noticed, what is left out? The last thing what is left out is, I think so, this benzene ring, which is not benzene, it is C6H5, which is phenyl, and from here one H is left out. So will I get nothing but the compound obtained over here would be benzene. Is the term clear? One small information. If you see over here, your H3PO2 is getting oxygen. So can we call it's an oxidation of phosphofinic acid? So can I tell that it is nothing but a reduction of benzene diazonium salt? Hence this topic in our textbook is by named mild reduction of benzene diazonium chloride. Is it term clear? So our correct answer in this case has to be, I think so you can see very clearly, it's nothing but B. Hence the correct answer is B. Now let's proceed with the next question. Kids, now next question again what we have got is nothing but based on diazonium salt, again statement 1 and statement 2. Now let's take the first statement. Statement 1 says that primary aliphatic amine reacts with nitrous acid to give unstable diazonium salt. This statement is a correct statement. If you want, you can take any example of aliphatic primary amine. Yes, treat this with NaNO2 plus HCl, correct? Because of that, what will happen? You will get nitrous acid form. Yes, and I will be taking also one more thing, little extra amount of HCl. Now what? When this will react, I think so what are you going to get is nothing but aliphatic diazonium salt, and aliphatic diazonium salts are unstable. Hence, it will further react with water and you get your product as an alcohol. So, when aliphatic primary amine is treated with nitrous acid, it gives unstable diazonium salt, which later on will give you alcohol and N2 gas. Is it clear? So, your first statement, what you have seen right now, as I have explained, is correct. Now, let us take the second statement. Now, when you compare this aliphatic with an aromatic primary amine, same way. So, what will happen? Again, you have got a nitrous acid. Now, from where we get nitrous acid? Because nitrous acid is an unstable. So, we have to prepare it by mixing NaNO2 plus HCl, correct? HCl. Now, what you will do? You have got an HCl over here. Now, what you can do simply, it will form nothing but what? Benzene diazonium chloride. But remember child, this reaction is carried out at 273 to 278 Kelvin. Why? Because your diazonium salt is stable at low temperature. But as per the question, what is given? If, see over here, primary aromatic amine reacts with nitrous acid to form diazonium salt, which are stable even at above 300. Now, which is not true, because suppose if temperature is not mentioned or it is given higher, that is, suppose if it is not mentioned, I should assume it as room temperature, or if it is mentioned also, what will happen? The thing is what? This diazonium salt only will react with water. What will happen now? Over here, your HCl will get lost. Yes, your N2 gas is going to be lost. Will I get nothing but the answer as phenol, and byproduct as usual is N2 gas and HCl. Now, my question is very simple. It's not the explanation of phenol. The question is very clear that your primary aromatic amines reacts with nitrous acid to form diazonium salt, and which are stable even at 300. No, this statement is incorrect, because above some temperature you can see it's unstable. So, your statement 1 is correct and your statement 2 is incorrect. Statement 1 is incorrect, it cannot be the same. Both statement no. Statement 1 is correct, but statement 2 is incorrect. Your correct option is C. So, your correct answer is option C. Kids, let us proceed with the next example. Now, here the next example is again what? We have got over here diazonium salt, and it has been treated under some set of reagents. Let us do this fast. I have got over here child a benzene ring containing N2 plus and Cl minus. Now, the first reagent what we have got is called as cuprous bromide. Yes, and along with that we have got an HBr. Now, kids, if you remember, when a diazonium salt has been treated with cuprous salt, This reaction is known as Sandmeyer reaction. Now, what happens in a Sandmeyer reaction, child? If you see in a Sandmeyer reaction, basically what happens, your N2 gas is lost, your H and Cl is lost. So, what will happen? Your diazo group gets replaced by a new group which is something called as bromo group will get attached. Hence, this is used to prepare bromobenzene. Now, what? The second step. Second step is nothing but a treatment of magnesium in presence of dry ether. Now, kids, this is one of the very common reaction. Whenever you see a magnesium on the arrow, that means it indicates it's a Grignard reagent. That means what will happen? You have to put a magnesium over here. It is going to be phenyl, magnesium, and then bromide. Now, this is nothing but my second reagent. Now, the last. So, what water is going to do in this? Now, if you remember one reaction, child, what we have got in syllabus, that whenever Grignard is treated with any solvent which shows acidic character, what will happen? Do you know that, child, this H is delta plus, which indicates it's an acidic character, and this is delta minus. Here, when you see Grignard reagent is nothing but what? Organometallic compound. So, whenever metal is attached to a carbon, your carbon obviously has to be minus and your metal has to be plus. What will happen? Your minus part will combine with this H, yes, and your Mg will get combined with OH. So, the product obtained in this case will be that benzene will contain 1H. That means it will be phenyl containing 1H basically would be a benzene, and the other byproduct would be magnesium with Br and along with that OH. So, in this case, I think so our answer what you see is nothing but a benzene. That means I will write over here, which you can't see up properly over here. Correct answer is D. Is it term clear, child? So, I will just mark it properly so that at least you are able to see. Is it done? So, let's proceed to the next question what we have. Now, over here, your next question what we have is this one. And what is it? The two monosaccharides of sucrose are held together by a glycosidic linkage between what and what. Now, basically this is a factual question, child. We know that a sucrose unit, yes, is nothing but what? A disaccharide. Now, basically what are disaccharides? Disaccharides are nothing but those compounds or those carbohydrates which on hydrolysis will give 2 units of monosaccharide. That means your sucrose is made up of 2 monosaccharides. Now, which are those 2 monosaccharides, child? One is we know it's a glucose unit, and second we know it's a fructose unit. Is it term clear? Sure, confirm. And one more important thing, child, we should even know that which isomer is used. Like in glucose, we have got alpha glucose and beta glucose. Same way, in fructose also we have got alpha and beta. So, remember in sucrose, we have got alpha glucose and beta fructose. So, this is what we should know. So, basically, first of all, what you should know is that sucrose is made up of alpha glucose and beta fructose. One more thing. Now, when a glycosidic linkage is formed, it is nothing but between 2 alcohol groups water is lost and you get glycosidic linkage. Now, the question comes is, which 2 positions are of the molecules where OH water would be lost? The case is, in case of glucose, it will be the C1 carbon atom, and in case of fructose, it will be C2 carbon atom. That means, as per this data what we have, we can see your glucose, what you have got. When you talk about glucose, glucose ka C1 carbon atom, glucose C1 carbon atom, and fructose C2, correct? Alpha of glucose and beta of fructose. So, the common example what we, as per the situation we have, the answer would be C, correct? So, your correct answer is C. Let's proceed with the next question, child. Okay, again the next question is again a factual little bit. Now what we have? Lactose. Now in this lactose discussion, child, when you see, again it's a disaccharide. Now when you again tell about the disaccharide, so again it's what? This compound on hydrolysis gives you what? 2 units. One is galactose and the another unit to which it is joined is glucose. Now the question what they have asked, what is a reducing part? Now this is a factual data which I had explained you in the class. Galactose is nothing but a part of a sugar which is a non-reducing part of the molecule, and glucose is nothing but a reducing part of the molecule. That means if they have asked what is the reducing part in the lactose, your correct answer has to be B. So your correct answer is B. Let's proceed to the next question, Bacha. Now next question what we have, again it's a very simple and factual data, so we don't have to spend over here much time. Which is a correct statement? Now the first statement, if you read starch is a polymer of a glucose. Yes, I think so, you know starch is a polysaccharide and the monomer unit present in that is alpha glucose. So yes, your first statement is correct. Now second, I think so we have to find out the correct statement, and the first statement is only correct, but let's try to see also. Amylose is a component of cellulose. I think so, no. Amylose is nothing but a component of starch only. So this is incorrect statement. Now, proteins are compounds of only one type of amino acid? No. Proteins are made up of mixture of different alpha amino acids. So even this statement is also incorrect. Now, in a cyclic structure of a fructose, there are 4 carbon atoms and 1 oxygen. If you basically see, child, in a fructose molecule, we have got total 6 carbon atoms, yes, and 1 oxygen, correct? So over here, I think so this statement is also incorrect. Fine. So this statement is also not proper. So if you check properly, only one statement is correct, and I think so your correct answer in this case is A. Is it term clear? Chalo, let's proceed with the next question. Again, it's a factual. Mark the incorrect examples. Now see, the first question given to you is first option, keratin and myosin are the examples of fibrous protein. Yes, correct. Your keratin and myosin is an example of a fibrous protein. It's a correct one. Insulin and albumin are the example of globular protein. Yes, it's correct. Glycylalanine is a dipeptide. Now child, if you remember, this name has got 2 parts. One is glycine and one is alanine. This is actually nothing but a combination of 2 alpha amino acid, and we have got a peptide bond, which hence the name is dipeptide. Yes, it's correct. Obviously now all 3 are correct, one has to incorrect. And if you see, enzyme and hemoglobin are derived proteins. No, this is incorrect, child. So the correct answer for our MCQ, which is incorrect example, is nothing but what? Your correct answer is D for our MCQ. Let's see the next question, child. Yes, denaturation of protein leads to a loss of its biological activity. Now basically, child, we know proteins, we have studied that protein structure is studied in 4 different levels as primary, secondary, tertiary and quaternary. And whatever the protein has got some biological property, yes, some of the properties are based on its structure. But now what happens when the proteins are heated, or either you add some chemicals to it, its pH changes. So what happens? Your protein gets precipitated. Now why it gets precipitated? Because basically there are some proteins which are globular protein. What happens? They have got tertiary structure, quaternary structure. Now those quaternary, tertiary and secondary structure gets destroyed, and finally it comes to primary. So over here what happens? In a denaturation of protein, what happens? I think so the option what is given, loss of both secondary and tertiary structure takes place, is the correct answer. So, your correct answer for this MCQ is D. Is it clear? Move on to the next question now. Yeah, now I think so it's about nucleic acid, and I think so we know some concepts behind that. Now here let's say we have got the main point of difference between RNA and DNA. Let's take it over here as RNA and let's take it over here as DNA. The first point of difference is only what these names. Now if you see over here there is an R and here there is a D. Now RNA is nothing but what? Ribose nucleic acid. So the sugar present in this is a ribose sugar, and whereas in case of DNA the sugar present is deoxyribose sugar. Now we know that the bases which are present, so please check over here, there are three bases which are common, A, G and C, common for both. Here also the basis what we have, that is A, G, C, is common for both, but the fourth base is different in both. In RNA you have got uracil, and I think so in DNA we have got thymine. So here the question is very clear. If you see, the main point of difference what we have got is presence of deoxyribose and thymine in DNA. I think so, yes, deoxyribose sugar is there and thymine is also there in DNA, whereas ribose and uracil in RNA. So I think so the correct statement, I think so what we have is nothing but D. So your correct answer is, what is the correct answer, Bacha? I think so it's B. Is it clear? Chalo. Next we'll move to the next question. Now, child, again this is a factual discussion little bit. What is the concept given to you? The concept given to you is, in both DNA and RNA, the heterocyclic base and phosphate ester linkage are at which position of sugar molecule? Let's say, bacha, this is a sugar molecule which I have drawn over here. Yes, here this is position number 1, here it's position 2, here it's position 3, here it's position 4. And if you see the groups what you have got in sugar, yes, over here you will see that the first position what you can see clearly is nothing but where your bases are connected, and here on the fourth carbon atom, child, there is one group called as CH2OH. Now here, if this is the fourth carbon, this has to be the fifth carbon. Yes, and we know that already bases have got some numbers, so sugar will get number as 1 dash, 2 dash, 3 dash, 4 dash and 5 dash. So now the question is what? Your heterocyclic basis is connected to the C1 position. Yes. And what about the phosphate? Phosphate will be connected to C5 position. So here you will see that your phosphate linkage means your phosphoric acid will get connected to this position somewhere. So your correct answer has to be in this case is your heterocyclic bases will be connected to C1 and your phosphate will be connected to C5. So your correct answer has to be C. So correct answer is C. Let's proceed to the next question, child. Now the pentaacetate of a glucose does not react with hydroxylamine indicates what? Now basically this is one of the concept where group of some scientists had told that glucose has got an open chain structure having an aldehyde group, but later on we have got some evidences which have informed us that glucose contains an aldehyde but in a modified form, and that's the reason glucose are present in the nature in the ring form. So now after indicating or after this observation, what we see, pentaacetate of a glucose does not react with hydroxylamine indicates only one thing. That means the scientists were thinking that aldehyde group is not there. Otherwise, there is no other observation we can have in this. So correct answer for the given MCQ is option D. Let's see the next question, kids. Now this is one of a very simple question what we have, child. Now it's about the IUPAC what you have. I think so one of the very common example, we can take the first example. We know that your select the long chain discussion. This can be your number 1 carbon, this will be number 2 carbon, this will be 3, this will be 4, this will be 5, and this will be the 6th one. This will be the 6th one. But now I think so no need to calculate each and everything. The reason is, if you have got one ene, I think so in entire example you can see one ene, you can see only at one place. Yes or no? You can see one ene at only one place, which is nothing but this example, which is this one, correct? And 2 all. So A has got third option. Now when you see A having a third option is not matching, not matching. A having a third option is matching. So I think so you do not need to solve other examples. I think so your correct answer in this case is D. So correct answer is D. Hope so, child, you have understood this. Now the next question what we have again, it's an IUPAC. Now basically rule says that you have to select the long chain which should include functional group carbon atom. So now over here what I'll do is, if you see alcohol comes at a middle position. So either you can start from this side or that side, but since double bond is there, your numbering will start from here 1, 2, 3, 4 and 5. So your double bond gets number 1. So it's a 1 ene, and I think so in 4 example you have got 1 ene at one position only. Yes. So your correct answer in this case is A. So your correct answer for this given MCQ is A. Let's proceed with the next question, child. I think so this is one of the questions what we have got now. IUPAC name of the following polyfunctional compound. Now basically whenever you have got this type of compounds, you should know that carboxylic is one of the functional group, ketone is one of the functional group, and aldehyde is another functional group. Now out of this 3, who is the main higher priority functional group? Obviously it's an acid. So your numbering will start from acid only. Point number 2. Over here the parent chain what you have got is a cyclohexane, and acid is the main functional group, but which is not a part of an parent chain, it's outside the parent chain. So you can't use oic acid as a suffix name, you have to use carboxylic as a suffix name. So I think so carboxylic acid is this and carboxylic acid is this. So oic word will be used when your carboxylic acid becomes a part of the chain. So your both options are not possible. Now if you start numbering it, this is the first carbon, this is second, this is third, and this is fourth. Since you have got one of them is a ketone group, other one is an aldehyde group. Now ketone comes at second position, but aldehyde comes at fourth position. And aldehyde has got a prefix name called as formyl. So I think so out of these two names, I think so the most common name would be a formyl. So this is incorrect, D, and your C is correct. So your correct answer is C. So hope so. This is child clear with this. The answer is C in this case. Fine. Let's begin with the next question, kids. What we have got on the screen is the correct statement about the compound A, B and C. You can see 3 structures and they have asked A and B are identical. A and B are diastereomers. Your A and C are enantiomers and A and B are enantiomers. Now the question is, first of all, if you see over here in the third structure, you can see 2 hydroxy groups are on the opposite side, whereas in this case you can see 2 hydroxy groups are on the same side. Now, first of all, if you have got same side, we can take these 2 examples and just check what has to be done. But now the problem is what? You can see acid group is over here down and acid group is over here. Now, what you can do? You just rotate this molecule. What will happen? Let's see. I have got over here structure A. Let's see. It's what? Over here on the screen I am writing it as CO. So, we are just 1 second, kid. Now, you can see on the screen you have COOCH3 group having over here a straight line having 2 OH groups over here on the right hand side, and here you have got H, here you have got carboxylic acid as compound A. Now, let us see the compound B. You have again the same type of molecule where you can see as COOH, and you have got over here COOCH3. Here you have again OH and H. Now, basically what you can see, suppose if I reverse this molecule like this. So, what will happen? You can check over here, this I am keeping it aside and just reversing it. So, when you reverse it 180 degree, the groups which are on the right will now come on the left. So, here can I put the over here as this group up. Now, the group which is there on the top part will now come at the bottom. Now, the group which you have got on the right will now come on the left. So, you have got OH, OH, H and H. So, this compound after rotation of that 180 degree, you can see both the compounds look like as you have got mirror in between. So, whenever if you have got 2 isomers, yes child, which are non superimposable but mirror images, we call them as enantiomers. So, basically as per a discussion, you can see the correct answer for us would be A and B are enantiomers. So, correct answer for this MCQ is D, which is nothing but A and B are enantiomers. Let us move to the next question, kid. Now, the next question what it say is, which of the following compound is not a chiral? Now, when you use the word as not chiral, that means we are talking about optical activity. Yes, optical active compound. Now, how to check that the carbon is chiral or not? So, basically there are some logic which normally we had discussed in the class, as whenever if you have got CH3 group, whenever if you have got CH2 group, whenever if you have got a doubly bonded carbon, and whenever you have got a triply bonded carbon, basically these type of carbon atoms will not be chiral. Basically means you do not have to check these carbon atom at all. So, now in this case, if you see the first example itself has CH2, CH2 and CH2. So, in this none of the carbon atom is chiral. So, as per the question, I think so our correct answer has to be A. So, correct answer is option A. Now, let us move further with the next question, kids. Now, this is the next question what you have got on the screen. The structure given to you is there, and they have asked, okay, it will show which type of isomerism. Now, before we start anything, child, you should know one thing. Whenever a carbon atom which is attached to 4 different groups, I think so we call that particular carbon as a chiral carbon, or we call it as a symmetric carbon atom. Now, if you check over here, this carbon atom, child, it contains 4 different groups. One is H, one is carboxylic group, one is methyl, and one is the entire group. I think so this carbon atom is chiral. So, I can put over here a strict sign which is an indication. So, it is this particular compound will show optical isomerism. But now the next question is, sir, you have got even a double bond also over here. Now basically whenever there is a double bond can show geometrical isomerism provided whenever if you have got a carbon-carbon double bond. Yes, the groups which are attached to a doubly bonded carbon atoms, let's say A and B, or let's say over here your X and Y. So condition is what? If your A is not equal to B and X and Y is not equal, then compound will show geometrical isomerism. That means in our example, if you see, our compound can show optical isomerism, because see, one more option is there over here C, where geometrical and optical both are mentioned, but our correct answer has to be optical, because this compound will not show geometrical. That means the correct answer is nothing but, in our case, correct answer is option B, which you can see very clearly. Is it clear, child? Sure. Let's begin with the next question, kids. Over here, the next question what you have got again is the geometrical isomerism. So that's the reason in the previous example I had given that doubly bonded carbon atom, the two groups which are attached to a doubly bonded carbon atom should be different. Then and then only the compound would show geometrical. Let's start over here now. You can see in the first case, this carbon atom which you can see, there are two groups which are different. But I think so, if you see the carbon atom having this chain and having this chain are alike in nature, and that's why this compound cannot show geometrical. Now if you see the next example over here, I think so, this carbon atom which is doubly bonded having two group difference, over here the chain and over here the chain, they are different, because you have got over here just a saturated carbon, here you have got a branch carbon. So this compound is the one which can show geometrical. Now as per the discussion, we have got the answer, as your correct answer is B. Let's see why the other example. Now see, in this case you have got a double bond, yeah. Over here if you see, over here if you see both the groups are same. So I think so, both these groups are same, that means for us no geometrical isomerism. In this case again, when you see a doubly bonded carbon, both the groups are, you can see, same, that means again this will not show. So in our example what you can see, the correct option or the correct answer is, I think so, option B, which shows geometrical isomerism. Correct? Let's begin with the next question, child. Now here, which are the next question is based on again the number of geometrical isomers in case of the compound with the structure. Now before we start anything, let's try to understand one thing, that do double bond what you have got over here can show geometrical isomerism? Answer is yes. Over here also, do your double bond what you have got over here shows geometrical? Yes. So I think so, these double bonded centers are called as geometrical centers. Now total number of stereo isomers, specially as per the example, it's a geometrical, yes, isomers. So if you see a question properly, it's the total number of geometrical isomers is equal to 2 raised to n, where your n is equal to geometric center. Now when you talk about geometric center, can I use a formula over here as the total number of isomers is equal to 2 raised to n, where your 2 raised to 2 will be the geometric center, your answer will be 4. So as per the discussion, our correct answer is 4. So, correct answer for the given MCQ is A. Let's begin with the next question, kids. Now, here child, we have got carbocations and they have asked a stability of a carbocation. So, basically when we talk about stability, there are some effects which need to be discussed, yes, and you should know the order of preferences of those effects. Like we have got one resonance, second is hyperconjugation, third is inductive. And when you see resonance is more dominating as compared to hyperconjugation, and then you have got inductive. So, let us take these examples only properly, as I will write the structure A once again, CH2 double bond CH and having C with two methyl groups. One you can see over here as CH3, another methyl group you can see as CH3, it contains a plus charge. Now, second example, this is example number A. The second example is again CH2 double bond CH and CH2 with plus. I think so, this is the example number B. Now, when you see the next example, what we have is CH2 double bond CH. Again, you have got CH with CH3 with that plus charge. This is example number C. Now, before we start anything, first of all, if you see in all these examples, you have got positive charge alternate to a double bond. Here also positive charge alternate to double bond. Here also positive charge to alternate double bond. That means in all these examples, we have got resonance. But now, apart from resonance, there is one more. The next carbon atom, the immediate next carbon atom to a positive charge is actually called as an alpha carbon. So, over here we can find it as alpha H. So, here you have got 6 alpha H, whereas in this case we do not have an alpha H. In this case again we have got a 3 alpha H, and if you see in all three examples we have got resonance. So, I think so resonance won't make much difference in this case, yes. So, our deciding factor will be alpha H. Here there is no alpha H, so I will just put it over here for a reference, 0 alpha H. Over here for the reference I will give it to S3. So, more the alpha H you have got, more is the hyperconjugating structure. If more is the hyperconjugating structure, more is the stability. So, what is the output of this? So, stability order. Now, stability order for our example would be, the one which is more stable would be A, then you will have got in the sequence a little lesser one would be C, and the least would be B. So, as per the stability order which we have got over here, you can see your correct answer is A, C and B. So, your correct answer is C. So, correct answer is C. So, I hope so kids you have understood this example. Let us try with the next question what we have. Now, here you can see this is nothing but and again carbocation. Now, in these examples of carbocation, I will just write it examples over here once again. So, this is nothing but a benzene ring, yes, having over here your CH2 group plus, correct. Now, what I will do is, I will take this example, I will put it over here, and like that I will take it as 4 examples which you had got as a question. Now, what is the basic difference in all these things? I think so the basic difference is nothing but a methyl group. So, I will just highlight that situation little bit. Over here you have got CH3. In the next example B you have got this CH3, and the next example you have got over here also CH3. Now, the question comes is, sir, how are we going to solve this? Point number 1. Now, the differentiating group what you have got in this case is a methyl group, correct. Now, what is the effect of a methyl group? The effect of a methyl group is nothing but first it is plus H in our example because it is attached to a benzene, and the another effect what it can have as a secondary effect is plus I. Now, same it is for this also as plus H and plus I, same way plus H and plus I. But now kids, you should know one thing which we have done already. Whenever if you have got a group at meta position, yes, resonance effect is not observed or delocalizing effect is not observed. Now when resonance effect is not observed, same way hyperconjugation is also nothing but abnormal resonance. So even you don't have to take this. Now that means which all effects will be considered. Now I'll tell you which effects you have to consider. First, in case of the first example, which is the A, we will consider this as an dominating effect. In this example, we have got this as a dominating effect. In this example, I think so we have got H as a dominating effect. Now from this, one thing is very clear. Oh, here no such group is there. So what will happen? If you now check, I want to find out the stability order, correct? So here the stability order would be, now listen. Child, you should know one thing. Which groups are there who stabilizes the carbocation? I think so electron donating groups, and I think so all these groups what you can see, all these groups what you can see are donating groups only. So this also will increase the stability, this also is going to increase the stability, and this is also going to increase the stability. That's clear. So out of 4 example, I think so the last example, which is a D as per the situation, will be the one which is least stable. Now out of hyperconjugation and inductive effect, I think so the maximum effect is nothing but hyperconjugation. So minimum effect is nothing but what? It's nothing but inductive effect. So here out of this 3, your second example, which is nothing but a B, will be over here. Now the fight is between example A and example number C, where I think so hyperconjugation is observed, and both the places hyperconjugation effect will be same, because hyperconjugation is not a distance dependent. So here I'll just do what? I'll not consider now hyperconjugation, I'll consider now your secondary effect. Now who is the secondary effect? Inductive. And I think so inductive effect depends on the distance. As it is more closer, it will have got a maximum effect. Obviously it will have a maximum effect. So it's again an increasing effect. So it's a maximum increasing effect, and again it's a increasing, but over here it's a minimum. So out of these two, who will be stabilizing it more? I think so the position where you can see methyl is at ortho position, that means your option A compound would have more stability than C. So as per a discussion, I think so A, C, B and D. So your correct answer has to be, your correct answer has to be C. I'll write it over here. Correct answer is C. Is the term clear? So kids, let's proceed with the next example what we have. Now kids, over here you can see very clearly 4 alkenes are given, and they have asked which one is more stable alkene. Now basically when you see alkenes, first of all, to find out the stability, we always check a sequence of dominating effect as resonance, but I think so in none of the examples we have got resonance. So the second effect what we have to do is hyperconjugation, which depends upon alpha H. So more the number of alpha H you have got, more stable is the alkene. So let's see how to find out the alpha H over here in this case. So over here I've just taken, this is nothing but your double bond. So this carbon atom and this carbon atom, you can see it's alpha, correct? So over here I think so both contains 4 alpha H. Over here if you see in this example, this is the functional group alkene. So this carbon atom is alpha, this carbon atom what you can see is alpha, and this carbon atom what you can see is alpha. So here we have 3, 2 and 2, total 7 alpha H's you can have. Is it term clear, child? Now in this example, if you check, this is an alkene, you have got over here and over here, this is an alpha carbon what you can see. So total number of alpha H's are again 4 in this case. In the last example, if you check, this is nothing but an alkene, the immediate carbon atom is alpha carbon. Here you have got alpha H only 1. That means out of all example, the maximum number of alpha H, what you can see is this. So, in a simple terms, more the alpha H, more is the hyperconjugating structure, more is the stability. So, your answer B has to be correct. So, your correct answer is B. Is it clear? So, kid, let's proceed with the next example what we have. Now, on the screen, I think so you can see one of the very common reaction what we have. For the reaction of phenol with chloroform in presence of KOH, the electrophile is. Now, bacha, you should know one thing, that whenever a chloroform reacts with KOH, it forms very important intermediate called as dichlorocarbene. So, the name of this compound is dichlorocarbene. And one more important thing, child, if you count the number of electrons, you can see there are 2 electrons. Here these are 2 electrons, and here 1 electron of Cl. So, can I call it a 6 electron system? And whenever if you have got electron less than 8, we call it as an electrophile. So, which is that electrophile which is used during this reaction? I think so the answer is dichlorocarbene, which you can even write in a condensed form as Cl, C, 2Cl and 2 electrons shown over here. Is it term clear, child? So, our correct answer has to be B. So, the correct answer is B for our example. Let's proceed with the next question, child. Is it done? Okay. Now, here you have got a next question, child. The order of stability of the following carb anion. Now, here you have got a negatively charged carbon atom, but whenever you get this type of question, just remember one thing. Whenever if you have got a cyclic ring, first always try to check aromaticity. And what I can see in this case is, over here in this example, third example, you can see over here cyclic ring is there, second planar, third part is conjugation, and last part is what? The number of electrons. So, you can see whenever there is a negative charge, it indicates one lone pair. Now, here if you can see, you have got 6 pi electron system. Yes, that means that it's obeying Huckel rule, and all other 3 parameters. That means this compound is aromatic in nature. Hence, if it is aromatic, it would have an extra stability. So, out of all 4, one thing is very clear, that your example number 3 is aromatic, it will be more stable. So, now let us first check. If you see in this A example, the third one is not the beginning, because it is more stable. So, you should start only with third. So, here also it is not possible, here it is not, here also it is not. Only the one example you can have over here, it is D. So, your correct answer, yes, in this case is D. Is it done? So, I think so this example requires only one information about aromaticity, and stability will be connected to it. Is it done? Let us proceed to the next question, kids. Now, here you have got one question called as correct order of nucleophilicity. Now, basically first of all, what is a nucleophile? The one which has a tendency to donate an electron pair. Now, the question comes is, your donating power will also depend upon electronegativity. So, can I make a statement as nucleophilicity is inversely proportional to electronegativity of donor atom. So, the one which is more electronegative atom will be a poor donor, and the one with the less electronegative atom will be a better donor. So, in case that is period number 2, when you come for carbon, nitrogen, oxygen and fluorine, your carbon would be having a minus charge, would be more better nucleophile. So, I think so in this our example, if you check methyl anion, I think so it is better. first most, then nitrogen, then oxygen and then fluorine. So our correct answer in this case is nothing but D. So correct answer for this MCQ what we have is D. So kids, let's proceed with the next question what we have. Now here, if you see this question is telling like that, consider the following compounds. There are 3 compounds given to us, 1, 2 and 3. Hyperconjugation occurs in. Now first of all, you should know the basic condition for hyperconjugation. There are 2 conditions. There are 3 compounds or ions you can tell they show hyperconjugation. One is carbocation, second is carbon free radical and third one is alkene. Yes. Now as per our example, if you see, I think so you can see very clearly free radicals is given. That means your condition number 1 eligibility is fulfilled. That means you can think of hyperconjugation. Now condition number 2, presence of alpha hydrogen which should be attached to sp3 carbon atom. Now I think so the first example if you check, this is nothing but and this is nothing but, which example, this one you can see is alpha but does not have an alpha H. Here also this is an alpha, it does not have an alpha H. That means your example number 1 cannot show hyperconjugation. If your example 1 cannot show hyperconjugation, that means it's clear your example B is cut and your example C is also cut. So now you are left out with only 2 examples, 3 and 2. Yes, that's nothing but A and D. Another problem, when you have got an aromatic ring, yes, substituted carbon, what you can see over here, yes, substituted carbon, what you can see over here, does not contain any alpha H, and I think so over here all phenyl rings are nothing but what, benzene rings only. So here don't have alpha H in this case also. So no alpha H for this example. That means even your example number 2 is not possible. Now only one example is left out. Let's verify. Here you can see it's an alpha carbon which has got alpha H. Is it clear? And some of the kids may even think this, sir, there is one more. I think so this is a bridge carbon atom, and bridge carbon atom having an hydrogen is also alpha, but it cannot be used for hyperconjugation, we have discussed. But over here the correct answer is what? Out of 3 examples, who can show hyperconjugation? Answer is third only. So correct answer is A. Is it clear, child? Let's begin with the next question then. So here the next question what we have is what? Which of the following carbocation is expected to be more stable? Now one thing is very clear, child, you have got over here cation, and you should know one thing very clearly, that is what? C plus. Which groups are there which will stabilize a carbocation? So now we have got in our list, one is electron donating group, and another category wise we have got electron withdrawing group. So now which groups are there who stabilizes the carbocation? So here, what is donating group? The one which has a tendency to give electron, and hence over here we have got all groups which shows positive effect like plus I, plus H, plus R. Same way, electron withdrawing group is the one which will show negative effects. So it's minus I, minus H and minus R. Now the question comes as, which groups increases the stability of a carbocation? The answer is electron donating groups only increases the stability, and electron withdrawing group destabilizes the carbocation. So now the question comes as, sir, over here I have got a nitro group which is an electron withdrawing group. Of course it's an electron withdrawing group and a plus attached to it. That means this compound will be least stable because of this effect is nothing but what? Electron withdrawing group. Now next comes as over here. Again in this example, if you see a positive charge is directly bonded to a nitrogen, that means over here also this nitro group will destabilize this positive charge because of electron withdrawing nature. So even this example is not possible. Now we are left out only with 2 examples. One is this and one is of example C and one is example A. But now again the next problem. Is this a positive charge alternate to a double bond? Yes, so resonance is possible. So when this pi electron will shift over here, the next positive charge, what are you going to get over here only? And hence again, this also what you can see. Again, you will see in this also that this carbocation also will be least stable. Now you are left out with one. In this case also, now some kids will tell that, sir, here also there is a resonance. Yes. So this positive charge after getting delocalized will come over here. After again delocalization, it will come over here. So the carbon atom to which the nitro group is attached does not get a positive charge. So out of 4, this one is much better. Hence, the correct answer is option C. Is it clear? I hope student this example or this point is cleared. Move to the next question. What we have over here, there is a very common example. What we have, tertiary butyl carbocation is more stable than secondary butyl. Now question comes is, sir, what is tert butyl? I think so. If you see, tert butyl group is this group, correct, with a dash, and secondary butyl is something with 4 carbon atom having over here a dash. Now what is the question? Is it given alkyl group or carbocation? So what I'll do is, I'll make this only as a plus, because this is only nothing but my carbocation, this is only nothing but my carbocation. Now my question is, let's put all hydrogens properly over here. It's CH3, it's CH2, it's CH3, and it's a CH. Now question comes is, out of these two, who is more stable? I think so they have mentioned already that tert butyl carbocations are more stable. Now question comes is why? The answer is, obviously whenever there is a carbocation or any stability has to be taught, first we think about resonance, which I think so you don't have any suitable condition for resonance. But we have got another condition which is hyperconjugation. So here if you see, there are total 3 H, 3 alpha H and 3 alpha H. There are total 9 alpha H over here in this example, whereas in this case you have got only 5 alpha H. Obviously, more the alpha H you have got, more is the hyperconjugating structures, and more the hyperconjugating structures you have got, more is the stability. Hence, what has been told is correct, but now we have to give the reason why, and I think so the reason is very clear. It's hyperconjugation what we have, and that's the correct answer, which is D. So, correct answer for this MCQ, correct answer for this MCQ is D. Is it clear, child? Let's move to the next question. The next question is, when the given compounds are monochlorinated, yes, racemic mixture is formed from. Now, if you check all these 4 examples, what basically you can do, you can take all 4 examples one by one and you can check. Yes, I'll just give you one logic behind that. Now, if you see over here, you have got a first example which is neopentane. Now, when you have got a neopentane, I think so this is the example. Yes, I'll just give you one example in detail so that others can be solved very easily same way. This is nothing but a neopentane example. Now, if you ask me, so when this compound will get chlorinated, what will happen? So, on chlorination, child, you will have only one product possibility over here. Why? Because there is no other type of hydrogens you have got over here. All 12 hydrogens are of the same nature. Now, if you check over here, I think so none of the carbon atom what you have got over here is chiral, correct? So, this compound will not give me, because what is racemic mixture? If a compound contains a chiral carbon, yes, it will show a formation of a racemic mixture, but over here I think so you don't have any chiral carbon, that means this cannot be the answer. Same way you can check another example which is B. So, over here we have got the example B. Now, when I take example as N-butane, what is N-butane? I think so there are 4 carbon atoms in a straight line. Now, as per a probability, yes, as per the probability, you can see very clearly there are 2 different types of carbon atoms. One is primary and one is secondary. If you tell me, I can write even a structure for you also, but this time I will not put H, just it's a carbon skeleton. Suppose if your primary H is getting substituted by Cl, or if your secondary H is getting substituted by Cl, what will happen? Over here I will get a primary chloride. In this case, I'll get secondary chloride. Now, when you put H's everywhere, it's CH3, CH2, CH2 and CH2. But in this case, you can have CH3, CH2, CH3 and H. Now, question comes as, sir, do we get over here some racemic mixture? I think so. Not in the first example, but yes, in the second example, you can check this carbon atom contains 4 different groups. One is methyl, one is H, one is Cl and one is this. That means the product what you have obtained is nothing but called as racemic mixture, which we indicated by plus or minus. So, I think so as per our discussion, we have got the answer. Your answer is B. Same way you can even try and check for C and D also. So, your correct answer is B. Let us move to the next question, kids. Now, what we have got next question is N-hexane and N-heptane when passed through chromium trioxide supported over alumina at 600 degrees centigrade, it gives you what? Now, basically, bacha, if you remember one chapter called as hydrocarbon, where there is one reaction in chemical reaction of alkanes, aromatization. Now, what is that reaction? The reaction is very simple. Suppose if you have got 6 carbon atom, which I can show here as N-hexane, correct? Now, under this condition, what is mentioned over here as chromium trioxide supported with aluminium oxide, and the temperature mentioned is 600 degrees centigrade. What will happen? You will get an aromatic compound. That means 6 carbon atom will form over here a benzene. But the steps to be shown in this what? First, it will get converted to what? First open chain compound will get converted to cyclohexane, and then further it will get converted to a benzene. Same way, let us think about the next example. This was the first case, N-hexane. Same way, we have got one more example. What is that? It's nothing but an heptane. So, in this case also, when you try, you know that it is going to give you an aromatic compound, and benzene has got 6 carbon atom. So, out of 7, your connect of first carbon will be with 6 to form benzene, and 1 carbon atom will be outside. So, can I call it a substituted benzene? And I think so both these compounds what you have got, I think so is what? In one case we have got benzene, and in another case we have got toluene, which is methyl benzene. So, I think so in our case, if you see example, what you have got is nothing but correct answer is C. Is it clear, child? Sure. So, here your correct answer for our MCQ is C. Let us begin with the next question, child. Now, here, child, if you can see, this is one of the questions, child, where alkene is given. One more reagent is given, which is Cl water, that means chlorine water. What is the product obtained? Now, basically, just see over here what happens. You have got Cl3, C, CH with double bond, correct? Now, treat this with chlorine water. Now, basically, when you talk about chlorine water, actually what happens? It forms HOCl is the part which is formed. Now, when you talk about HOCl, the positive part in this is nothing but a Cl, and negative part is nothing but OH. Now, what happens? I think so it's very common reaction what you have studied in case of alkene addition reaction, where you have got Markovnikov addition. Now, in that case, basically what you should think is, suppose while addition your pi bond is not going to be there, it is going to be broken. So, first of all, I will write it over here as Cl3, C, CH and single bond CH2. Now, the question comes as, child, the first step of addition is only of Markovnikov is formation of carbocation. Now, the question comes as, out of these two options what you have got? Pi bond kahan pe tha? Yahin pe tha bachcha. So, when this pi bond suppose it break, the possibility number 1 positive charge can be over here, or possibility number 2 positive charge can be over here. Now, out of these two carbocation, which carbocation is more stable? Now, if you see this group what you have got over here, now this group will be showing over here as your minus I effect. Yes, and if it is showing a minus I effect, basically what will happen? It's very common that it is showing an electron withdrawing group. Yes, an electron withdrawing group destabilizes the carbocation. It destabilizes the carbocation. That means our example, what you have got over here, this carbocation is not stable. So this carbocation is stable. So here you have got a plus. That means your negative part will go and attack over here, and your positive part will go and attack over here. So the final answer would be of this type. You have got Cl3, C, C, H and CH2. This carbocation is more stable. So think over here this is plus. So here your negative part will come, and over here you will have got your the other part. Is it clear, child? So correct example for our case is nothing but your example B. So correct answer is B. Let's proceed with the next question, kids, then. Chalo, over here I think so one of the very common question. C6H12 compound is given to you. A has a chirality. Now what is chirality? Obviously it's a presence of a chiral center where compound will be optically active. Now the question comes is, on hydrogenation it gives you a product which is B, and because of this reaction its chirality is lost, means optical activity has been destroyed. Now for that what I will do is one simple case. You can take all 4 examples but in a bond line. I have got over here a pent-1ene example and with one methyl group as the example A. Now second example what we have is this, which is nothing but we have got total 5 carbon atom, second position double bond, and second position only you have got methyl. Now see, we have got over here butene. Now when you write a butene, it's nothing but like this, and having 2 methyl groups, one is at second and one is at third. And last example is D. We have got but1ene. So I'll write it over here as but1ene, first position, and on the third position I have got 2 methyl groups. So this is the third position where there is a methyl group. Is it done? Now the question is what? C6H12 has got a chirality. Has a chirality means what? A compound has got a chiral carbon. Now before you go ahead, do one thing. Can you check a chiral carbon atom in this only? I think so. Here you can see a chiral carbon atom very well, because you will have got one ethyl, one vinyl group, one methyl and one H. Yes, in this I think so you don't have any chiral carbon atom. So this example cannot be the case. So your B option is not possible. Now in this example also you don't have any chiral carbons, because your question is only telling that your starting material has got chiral carbon. But here you don't have a chiral carbon atom. That means even this option C is not possible. Okay. Now if you see the example D, now D also does not have any chiral carbon atom. That means even this is also not there. So only one example which you can see can fit under this condition, and that's nothing but your option A. And if you want, we can do one extra step in this, as can you do hydrogenation of this molecule in presence of catalyst? What will be the answer? Your double bond will get lost and you will get a single bond. Now if you see, this compound has lost its chirality because both the ends have become same. So the question correct is, as per the question, your option A is more appropriate. So your correct answer is A. Let's proceed to the next question, kids. What we have? Question number 39. Now this is one of the very common questions what we have based on topic ozonolysis, but let's see how to check. Now here you have got an alkene, and here the product what you have got is an acid. So you can see a lot of oxygens are there. That means there is some process called as oxidation. Now here out of this, first of all try to eliminate. Lithium aluminohydride is a reducing agent. So here if oxidation has to be carried out, I cannot use this. Now you have got total condition 1, 2 and 3. All 3 of them are nothing but ozonolysis, but you should know one thing. Always in a second step of ozonolysis, always on ozonolysis, we have got zinc with water as per the syllabus, correct? Which is nothing but called as reductive ozonolysis, because always alkene, whenever it gets ozonolized, yes, under reduction condition you get aldehyde. But if it is oxidizing agent condition, then it will be carboxylic acid. So here if it's carboxylic acid, it has to be oxidized condition. That means first option, your zinc plays a role of reduction. तो ये तो काम नहीं आएगा बच्चा. Even your dimethyl sulfide also will be an acting as a reducing agent. Hence this also won't work. So your correct answer has to be water. And that is one question bacha you have got in syllabus. Explain the role of zinc during hydrolysis in process called as ozonolysis. Again the answer is this same. So now over here you have a correct answer, and that correct answer is nothing but C. So correct answer is C. Let's begin with this question, kids. Now on the screen you can see, as in the middle given, it's an alkyne, and on the arrow they have given HgSO4 and H2SO4 giving product A. Now if you remember this reaction, child, it's nothing but hydration of alkyne, where one logic has to be remembered that addition of water will take place according to Markovnikov rule. Whereas if you see the other example on the other side, where on the arrow it is given as BH3 with THF and it's H2O2 and base. Here you should remember it's a hydroboration reaction where addition of water will take place according to anti-Markovnikov rule. Now what it means, let's write. I'll just take over here an example. What we have is alkyne, which is CH3, single bond C, triple bond CH. Now over here I'll give you two conditions what have been mentioned over there. First, you have got HgSO4, and along with that you have got H2SO4. In this case, child, I have taken over here the second condition, which is BH3 THF, tetrahydrourine of urine, and the second step what they have given is H2O2 along with the base. Now what would be your product A and B? Now child, the logic is very clear. You have to add a water molecule according to Markovnikov, and in the second case you have to add according to anti-Markovnikov. So let's write first the skeleton. Don't put a pi one. Over here this is the skeleton. Over here also this is the skeleton. Now first case, as per Markovnikov, you need to add O over here and H2 over here. So 1H and 2H will combine to give you H3. In the second example, you need to add according to anti-Markovnikov. So oxygen will be added over here and you'll have got 2H over here. That means this is nothing but my compound A, product A, and this is nothing but my product B. So now if you see the options given to us, where A is the product what we have got as ketone, which is nothing but this, which is matching, and the second product what you can see B is nothing but this side, where B is also matching over here, which is propanol as an example. So your correct answer is B. So here I'll write just correct answer is B, what we have got of this MCQ. Correct. Let's proceed to the next question, child. Now here, child, if you see, the next question is, which of the following reacts with the aqueous solution of that reagent? I think so this reagent is nothing but silver ammonia complex known as Stolins reagent. Now if you remember, in a chapter called as an alkyne, there is one test called as laboratory test for identification of terminal, or you can call it as acidic alkynes. That means over here, this case what we have is for alkynes. So here alkenes will not perform over here. Now the question is what? Out of these two, which alkyne contains an acidic H that will react with Stolins reagent to give you white PPT? Yes, and I think so terminal alkyne is the one which is nothing but this. So your correct answer in this case is nothing but C. So correct answer for a given MCQ is C. Now let's begin with the next question then, kid. Over here now they have given the treatment of methyl magnesium bromide with the alkyne produced. Now if you remember in the previous example only I have told that your terminal alkynes are acidic. So let's have a discussion. Suppose if I have got a methyl magnesium halide and if it has been treated with an acidic solvents which I had mentioned if you remember prior. So here can I use this as an acidic compound where it contains an acidic H where it will be delta plus, this carbon atom will be delta minus. Here also you have got delta plus and you have got delta minus. So here you know whenever a metal is directly bonded to a carbon atom, yes, I think so we know that metal will be positive, so your carbon will be negative. So here your Grignard reagent acts as a nucleophile. So nucleophile will always try to attack the acidic H. So here the product obtained would be CH3 with that one H. I think so the name of this compound is methane. And the byproduct obtained in this case would be Mg with X. And the remaining part what you need to join is C triple bond C with CH3. Now the question is what is the product? I think so our correct answer what you have got is nothing but methane. So correct answer for this MCQ is A. Let's proceed with the next question, kids. Now here this is nothing but a question number 43 you can see, and they have asked which of the following is incorrect comparison. Means they have given over here stability comparisons of the compound. Now you can see the first compound what you can see is anti-aromatic. And this compound what you can see is a non-aromatic, and out of these two, non-aromatic is more stable than anti-aromatic very clearly, so this is correct. Correct? Means what? Correct in means of this is a correct answer. We have to find out what is incorrect. Correct? Now, if you see the next example, yes, it's nothing but B saying that this is again aromatic and this is again a non-aromatic. And I think so aromatic is more stable than non-aromatic. So you can tell like that even this question option is also given correct. Now in this example if you see, here you have got again aromatic. In this example if you see, it's again a non-aromatic. Now out of aromatic and non-aromatic, who is more stable? Aromatic is more stable than non-aromatic. So over here also this comparison given is correct. Now here, if you see this compound is anti-aromatic and this is given as non-aromatic. So generally, you tell me who is more stable, aromatic, non-aromatic and anti-aromatic. When you compare, your anti-aromatics are least stable than the non-aromatic. So over here in this case, this option what you can see is not given properly framed. Hence our correct answer is this because they have asked what is incorrect. So your correct answer is D. Let's proceed with the next question, kids. Now, kids, this is one of the very good question you have got of NCERT. I think so whenever if you have got an aromatic ring and alkyl halide with AlCl3 on the arrow, it's a Friedel-Crafts alkylation. Now what is Friedel-Crafts alkylation? Let's have a discussion over here. I think so I have got a benzene ring over here and it has to be treated with this molecule, which if you want I can write it in a bond or line only as it is given with Cl. Correct? Now what is the reagent you have got? In this case you have got a reagent called as, which is nothing but AlCl3. Now what is the first step? Is nothing but your Cl will come out and will you get nothing but some carbon cation over here, and that carbocation is a primary carbocation. But now we know that if there is a scope of rearrangement you should do. So here if you see, there is one hydrogen. Can I have an hydride shift? After getting an hydride shift, the molecule is going to be of this type. This bond, and this bond. And you will have got a plus charge over here. I think so this is an electrophile. Yes. And benzene likes to undergo electrophilic substitution. So this electrophile what you have got will attack to this benzene. So the product obtained in this case is going to be tert butyl benzene, which is our answer. So this is our product what we have. So out of this 4 option, the most appropriate option what you can see is nothing but answer B. So correct answer is B. Let's proceed with the next part then, kid. The last question what we have on the screen is, in the compound given to you, what you can see, electrophilic substitution occurs. Yes, we know that. The substituent E are methyl, then you have got CH2Cl, CCl3 and CHCl2. The correct increasing order towards electrophilic substitution is, now the question comes as child, first of all you should know electrophilic substitution reaction. So we can use one abbreviation what we know, aromatic electrophilic substitution reaction. Yes, will increase due to presence of electron donating group. Now the question is, what we have with us over here. Let's take an example first. If I have got a benzene ring, you can see very clearly. Yes, and it has got some group over here. So what I'll do is, I have got 4 examples you can see. So I'll take 4 examples over here. So this is nothing but my example number 2. Same way over here, I'll take another 2 such units over here. Now I'll put all the groups in this. So let's take the first group as the situation wise CH3. The second group we have got is CH2Cl. The next group what we have got is CHCl2, and the next group what we have got is CCl3. Now the question comes as, what type of effect it shows? Now when you see this, carbon contains over here total 3 alpha H, and it shows plus H effect. In this case also if you see, it has got 2 alpha H and it shows even a plus H effect. In this case also you have got an alpha H, 1. It shows also plus H effect. Now here if you see CCl3 when attached to benzene, it does not contain alpha H. Yes, 0 alpha H. And not only this, even this group if you see shows minus H. So if you see which groups are there who enhance, in short, I think so this group will increase the reactivity, even this will increase the reactivity, this will increase the reactivity, this will decrease. So if you ask the stability order, or the, you can call it as reactivity order, correct? So let's write reactivity order, that is also in the increasing order. Increasing reactivity order is the one which is lowest we have to write first. So that will be CCl3, the one which will be the lowest. Then the better would be CHCl2. Then better would be for a reaction would be CH2Cl, and the best for electrophilic substitution out of this 4 would be CH3. So the correct answer I think so what you can see is exactly which matches as per the option is option D. So the correct option or the correct answer is option D. So kids, I think so we have completed all the questions. Now, only one thing is, if you still have any doubt, come down to a branch and you can coordinate to us anytime you require. But right now, I hope so you have understood with all the examples which I have explained. Is it done? Thank you very much. Take care, child.